Alright class, let's tackle the last two questions, 3 and 4, on your tree diagrams class or homework assignment. Number 3 says, you flip 3 nickels at the same time. What are the possible outcomes? Now we've already done 2 coins on the other side of this sheet. All we're doing now is we're adding 3 coins, or adding a third coin. So when you have a tree diagram now, class, you think about this. If you're flipping 3 nickels, that means you've got 3 different events happening. Nickel 1, nickel 2, and nickel 3. So how I would do this is I would just write in this level. This is, let me see if I can get this to be different color. This is nickel number 1 on this level, so all across this level is nickel number 1. The next level is going to be dealing with the outcomes of nickel number 2, and the third level is dealing with the outcomes of nickel number 3. Now we know, class, if we're asking for possible outcomes, we care about what the coin lands on, which side it lands on. So we don't care about that they're nickels, we already know that. We don't care they're coins, we care about the outcomes, and we know the outcomes of flipping any coin are heads and tails. So nickel number 1 can land on heads or land on tails. How many sides will make us happy? Well, just one side, the head side. How many possible sides are there on a coin? There are 2 possible sides. So our probability of landing on heads for nickel number 1 is 1/2, and the same for tails. And in fact, we'll be repeating this a lot, class, because you'll see in the next level of your tree diagram, let's say the first coin lands on heads. Well, the second coin could also be heads or tails. And of course, if we land on tails with nickel number 1, we could also have heads or tails on nickel number 2. And it's the same thing on nickel number 3. Nickel number 3 can land on heads or tails. If it got heads, first coin, land on tails, land on heads, second coin. Third coin can be either heads or tails. And that's the same across the whole thing. So what we're doing here, again, in the tree diagram, we are mapping every possible outcome combination. This will be a little repetitive, but remember, it doesn't matter what happened with the first nickel. Second nickel doesn't know what the first nickel did, and that means probability of landing on heads in the second nickel is also 1/2. Tails is also 1/2. Same thing in this event. First coin lands on tails. Second coin doesn't know what happened, so it can land on heads or tails. And the third coin, same way. And these are independent events. They don't know. One event does not know or is affected. Sorry, one event is not affected or does not know what happened in the previous events. So they're independent events. Therefore, the probabilities aren't affected from one event to the other, so they're all just going to be 1/2. Well, now, class, we have 3 events. So now, as you go down our tree diagram, as you move down our tree diagram, the probability of getting heads, of landing on heads, and then landing on heads again, and then landing on heads again is 1/2 times 1/2 times 1/2. I'll write that out for the first one so you guys see that this is 1/2 times 1/2 times 1/2, which is 1. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So we have a probability of landing on heads all 3 times is 1/8. And in fact, if you look at every branch, landing on heads, landing on heads, landing on tails, it's also 1/2 times 1/2 times 1/2. So every one of these branches is actually the same. Doesn't always work out that way, but in this case they are independent events. We're doing the same thing over and over. So the probability of these 3 outcomes happening in a row for each branch is 1/8. And now, class, once you get that last level done, don't forget, add up all of the final probabilities. We got 1, 2, 3, 4, 5, 6, 7, 8. All these probabilities add up to 8/8. We are good to go. Our tree diagram is accurate. And at this point, you ignore all the other probabilities. The only one you care about is the last one, which is the probability of that sequence of events happening. In this case, again, first coin lands on heads, second one on tails, second one on tails, 1/8 or a 1/8 probability. Alright, so letter A. What is the probability that only, it's a very important word, only one of the coins will land on tails? Only one. Class, only. Make sure you get that. Only means we're only allowed one coin to land on tails. Both of the other coins have to land on heads. Let's take a look at our tree. Land on heads, heads, heads. No good. Heads, heads, tails. There's an event where one coin landed on tails. I like that event. That one makes me happy. So I will write the probability. Heads, tails, heads. That one's also good. One coin landed on tails. Heads, tails, tails. No good because two of the coins landed on tails. That's not matching the event that we want to have happen of only one. Tails, heads, heads. That one's good. Tails, heads, tails. No good. Tails, tails, heads. No good. Tails, tails, tails. No good. So we just have a probability of one coin landing on tails is just 1/8, 1/8, and 1/8. Remember, class, we always add our fractions when we're doing a probability tree. So in this case we have 1 plus 1 plus 1 is 3. The denominator is the same. It does not change when we add fractions. 3/8 is equal to 0.375, which is 37.5%. Let's take a look at the next one. What is the probability that at least two of the coins land on tails? At least two. That means we're going to be happy if two of them land on tails, and we're also going to be happy if three of them land on tails. 0's no good, 1 is no good, but 2 is good, and 3 is good because we're looking at least two coins landing on tails. Take a look at our tree. Heads, 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 no good. Heads, heads, tails, no good. Heads, tails, heads, no good. Heads, tails, tails. Yep, we got two coins landing on tails there, so we've got one branch that makes us happy. How about this side? Tails, heads, heads, no good. Tails, heads, tails. That one's good. We got two tails there. Tails, tails, heads. That's good. Got two tails there. And tails, tails, tails. Now that one, class, that still makes us happy because at least two of the coins landed on tails. All three being on tails is still something that makes me happy. So we've got our branches that make us happy. Let's add them together. And we end up with 4/8. Put that in your calculator, 0.500. It's exactly 50%. So here's our answer to letter A. Here's our answer to letter B. There's our first one. Let's go to the next tree. I think I'll have time for this. Let's find out. Actually, what I'm going to do, class, is I'm going to stop this video. I don't want to rush this one. We'll stop it and we'll pick it up on the next one.